In this lesson, you will learn about points, lines, and planes. So beginning with our first term, a point. What is a point? Well, a point is described as an exact location in space. A point has no size and is represented by a dot. An example of this would be maybe like the pixels on a computer or television screen. And then the way we can name a point is with a capital letter. So here's an example. Here we have a point, it's just a dot, and we can name it with a letter. So this would be called point A. So when you write this out, you just write point and then A, like that. And then in math notation, we can write it as point A, like we can say it like that, or we could just use the letter A. So if we were talking about point A, just put the letter A for point A. All right, so that's one of your most basic definitions here in geometry. And then from that, we can kind of build to get some other definitions. Next, we have what is called a line. And a line is made up of points. Now, the way we can describe a line is it extends in two directions without ending in a straight path. A line has no thickness. And the way we can represent this is, let's say we had a line right here. So notice this line is going forever in both directions, two different directions, and is in a straight path. So this would be a line. And then the way we can name this is by using 2 points on the line. So a line, there's an infinite number of points. There's the points, number of points on the line is infinite. It keeps going forever, but we only need 2 points on the line to name it. So here, if we have points A and B on the line, we can name this as line AB or line BA. So we could write it out in words like this. We have line AB or line BA. But in math notation, we would write it like this, where we use the letters A and B, write them next to each other, and then we put a line symbol above it. In case you can't tell with the typing, okay, we just take the letters, and then right above it, you draw a line to indicate that it's a line. So this would be line AB, or we could switch the letters around of the 2 points and write this as line BA. So that would be the same line in this case. Our next term is line segment. Now a segment is a portion or a section of the line. So it is a portion of a line and it has 2 endpoints. All right, so here's a picture of one. Here we have a line segment going from point A to point B. Notice it does not keep going forever. It does not go past points A and B. It stops right at those locations. So it's a section or a portion or a segment of the entire line. So this would be a picture of a line segment. Now, if you were to express this in math notation, we could write out the word as segment and then AB, or segment BA, just like we did with the line. Just pick the endpoints in this case to indicate the name of the line segment. Now in math notation, we can also just write it with the letters A and B, or B and A, and then just put a line segment above it, like that. So notice the difference. Okay, this would be line segment AB. So we just draw a segment above. And then we had on the previous slide a line. So a line AB. Notice the difference. The line has the line symbol above it. A line segment has a segment symbol above it. So those are different. Make sure we have the correct one. Now some other terms to know. One is collinear points. So the prefix co means with. And then linear, we see the word line. So this literally means with the same line. So that's what collinear points are points that are with or on the same line. So here's an example. We have points A, B, and C. In this case, these 3 points are collinear because they are with or on the same line. Whereas over here, we have points A, B, and C. They are non-collinear because they're not on the same line. So make sure you know the difference between collinear and non-collinear. Our next term is the word plane. So a plane can be described as a flat surface that extends in every direction without ending. And it has no thickness and also has no edges because it keeps going forever. So a good example of this would be maybe like a wall or a floor. All right, so that would be a flat surface. But in real life, so like a plane is supposed to extend forever in every direction. In real life, we don't really see it extending forever, right? Like a desktop or a floor or a wall or a ceiling, those all have definite edges, definite endpoints, right? So in real life, there's not a true plane in the geometry sense, but for everyday purposes, we can call it a plane. And same thing for line, by the way. A line keeps going forever and ever in both directions. And in real life, we don't really see that because, here on the Earth, everything we see has a definite beginning and ending point. All right, so, but in geometry, a line would go on forever and ever without ending. Now, the way we can name a plane typically is with 3 non-collinear points on the plane. And a picture of this, by the way, if you were to draw a picture of a plane, so a plane keeps going forever without ending, but if you had to put it or draw one on a sheet of paper, you would kind of draw it like this. So it's a slanted rectangle. This would be called a parallelogram, but it's going to look something like this. So it's a flat surface, and then on it we have 3 points. All right, and so we just use the 3 letters, three different points on the plane to name it. So we can express this as plane, and then we could just write the 3 letters. So plane DEF, or we can do plane EDF or EFD. It doesn't matter the order in which we write the letters for the plane, as long as we have 3 points that are not on the same line to name it. All right, so make sure you know those terms. We have point, line segment, plane, and then collinear versus non-collinear points. Now, some other terms to know, dealing with points. All right, so if you have a point, you can actually graph points on something like this. So this graph here that we see, a name we can give to this is a coordinate plane. So we see the word plane. A plane is a flat surface. So a coordinate plane is a flat surface where we can graph points on in different shapes. Another name we can use for this is a Cartesian plane. This is named after the guy Rene Descartes. So Descartes is how you spell his last name. So notice the Carti right there, Cartesian plane. That's where the name comes from. So you can use either of those. Typically, we'll probably use coordinate plane when we describe it. So on the coordinate plane, there are some different parts to be aware of. First off, we have what's called the origin. Origin means beginning, and that point, that location here on the coordinate plane is this point right here. And that point, notice, is where these 2 lines intersect. We have this line going up and down, this vertical line, and the line going left and right, which is the horizontal line. All right, those 2 lines that we see, the 2 main lines, are called axes. So the plural is axes, looks like axes, like a battle axe, but it's pronounced axes because it's plural for the word axis. So we have 2 different axes. We have the x-axis, which is this horizontal one, and then we have the y-axis, which is going to be the vertical one. So make sure you know those terms here on the slide. And if you forget which axis is which, like which one is x, which one is y, one way you can remember this is if you take the letter y, and extend this part of the letter, just bring it down. Notice what's created is a vertical line. So the one going up and down like that, that's your y-axis. All right, and then the x-axis is the one going across left to right. All right, so that's maybe a way to remember the difference between those 2 axes. All right, now with this, with the coordinate plane, we can graph different points. So to graph a point, we use what's called ordered pairs. An ordered pair, you see the word pair usually means 2 of something. So what we have is going to be 2 numbers. So we have a number here and here inside of parentheses. So we have 2 different numbers where the first number is going to be your x value, and then your second number is your y value. All right, so just like the alphabet, right? X comes before y. Same thing with an ordered pair. X comes before y. Now we can put any numbers in here. So let's say we use the number 3 and 1. So as we said, 3 would be your x value or x coordinate, and then 1 would be your y value or y coordinate. So how do we use all of this? How do we use the x and y coordinates? How do we use ordered pairs on the coordinate plane? Well, here is some examples. Okay, let's say we were to graph point A. And let's say point A is the point 3, 2. So here's how this works. So the first number we said is our x value. The second number is our y value. So we're basically treating this right here, this x-axis. Okay, this is like the number line. So think of a number line where like right here is 0, right? Then we have 1, then 2, then 3, 4, 5, etc. All right, so those go up. Those are positive numbers. And then to the left would be negative numbers, right? That's how number lines work. -1, -2, -3, -4, -5. All right, so that is going to be your x-axis, remember. So what we can do is we can use this x-axis, use this number line here, left to right, to figure out how far do we go for the number 3. So the number 3, that's your x number. So on that number line, try to find 3. Well, 3 is right here, right? 3 is over to the right 3. So we have to go to the right 3. That's not our final answer, but that's going to be how far to the right we go. But we also need to account for the y value. So think of this vertical line here as another number line. So think of this as two different number lines, one going left to right, one going up and down. Where this one going up and down, when you go up, that is going to be positive numbers. So +1, +2, +3, +4, etc. And then when you go down, that would be negative numbers, like -1, -2, -3, -4, -5, etc. So going up is positive, going down is negative. To the right is positive for x, to the left is negative for x. All right, so we already said we have to go over 3 to find our x value, but we need to go up 2. This is a +2 for y. Remember, up and down, this is your y-axis. So this tells you how high up and down do we go. So we have to go up 2 to figure out our height. So we have to go to the right 3 for x, and then we have to go up 2 for y. So to the right 3, up 2, that takes you right here to this point. So that point is our point A. So point A is right there. All right, let's try another example. Here we have point B. B is given to you as 0, 4. So 0 is your x value, 4 is your y value. So x would be left and right, right? This is your x-axis, that's your horizontal number line. So x, we're going over 0, which would just be right here in the center, right at the origin. And then y is 4. So for y, it's +4, so that means we go up 4 in the positive direction. So we go up 4 over 0, that takes you right here to this point. So right here, that would be point B. Can you see that? Right there is point B. All right, let's try another one. Here is point C. This is at -3, -1. All right, well, -3, that's your x value. -1, that is your y value. So for -3, for x, we have to go to the left 3 on this x-axis. We go to the left 3, that takes you right here to -3. And then you go down 1, because y is -1, and negative for y is down. So we go to the left 3, down 1, to get this point right here, and that would be point C. Let's try another one. Here we have point D, and this one is at the point 2, -3. So see if you can do this one. Where would this point go if it's 2, -3? Well, 2 is your x value, -3 is your y value. All right, so x is +2. So for x, that would be to the right 2 on the x-axis. Y is -3, which means we go down 3 in the negative direction for y. So 2 to the right, 3 down. That takes you right here to this point. So that point right here would be point D. Here's another one. We have point E, and this one is at the point 2, 0. So where would that one be? Well, 2 is your x value, and then 0 is your y value. So for x, we have to go 2 to the right in the positive direction, +2. So 2 to the right, and then y is 0, meaning it does not go up or down. It just stays right there on the x-axis. So your point would be right here, over 2, up 0. That would give you point E, right there at that point, just 2 to the right. All right, so make sure you know how to graph. So here are a couple examples. You can try some more on your own, but that is the thought process. The first number is your x value, and the second number is your y value. So for x, positive is to the right, and then negative is to the left. For y, positive means go up, and then negative means go down. And that concludes our lesson for today. We will see you next time.